Alrighty. Had to go around the world to do the same thing, but we got it going. That's the only thing that matters. Alrighty. So, bias, for those that are still talking and not listening to me and being rude. Bias is when you see tendency. When you see a poll or a survey show a certain tendency. Can this be done with the questions that's being asked? Yes. It can be done with the pictures or the graphs that are being shown. It could be done with polls being shown. That's one of the big problems that a lot of people are starting to see with the media. They're starting to see all these polls come out, and they come out right before a primary, or they come out right before an election. And a lot of people are saying, why are they coming out right before the election, and why are they saying the opposite thing that the other polls have been saying? Because some statisticians are inclined to be, what do you call it, biased or dishonest. And they try to make the statistics say this, so the polls will say this, so people will believe this. And anybody that says that there isn't dishonesty in statistics is wrong. There is. There's a lot of statisticians out there that are biased. And that's why you have to, I don't think anybody's going to be biased in presenting the projections for Michelin's, damaged tires in the year 2017. I don't think you're going to see much bias there. But you may see bias in a office that somebody's running for. Or you may see bias for a presentation of slaughtered seals in the Arctic or whatever. All right. When there is a passion behind something, chances are you might see bias in some of your statistics, and you have to be careful. So the best thing to do is look at all the polls. If you get confused about political polls, what website? Does anybody know the website you go to look at all the polls? It's called realclearpolitics.com. And what that website does is it takes all the polls, like 30, 40 polls, and it puts them together and kind of crunches it down, even with the outliers. Well, I think it throws out some outliers. And it takes the polls that are normally generated, and it looks at them, and it looks at how many that there, and it looks at the margin of error, and it puts them together and averages them, and that way you get a real poll out of several polls that are similar. And it's a real good site. So you might want to put it in your notebook as a site to remember, not for math, but for your other courses, because it not just covers political polls, it covers all polls conducted in the United States. So it's called realclearpolitics.com. I think it's called realclearpolitics.com. Okay, so that's another website you can look at. How can you bias the questions? Well, you could say, instead of, the baby seal thing, I'm just making it up. Do you think that clubbing baby seals on top of the head with a mallet is humane? All right, that's a biased question. Anytime you say something like clubbing anybody on the head, what are most people going to say to that question? No, I don't think that's right. That's a biased question. Do you think killing of seals is right? That's a biased question. So you got to be careful how you ask questions whenever you're doing any kind of poll. You've got to keep it neutral. Remember, the secret to good statistics is being neutral. Kind of hard to do, but be neutral. Do you oppose the reduction of estate taxes? Do you favor or oppose the reduction of state taxes? See, when you put, do you oppose reduction of state tax, what would you call that? Would you call that a positive or a negative question? Negative. If you have mostly negative questions in your survey, you're going to come up with negative statistics, which is biased. You're setting the poll up to be negative. A lot of people don't even think about stuff like this. Wait till you start getting polled, and you start getting questioned. Do you think that Donald Trump is a jerk? Well, that's a negative question. Do you think that Hillary is an angel? That's a biased question. Most people are going to say, yeah, because I have no idea what else she's done. Or people are going to say, yeah, Donald Trump's a jerk because I listen to the media. You know, they're not going to answer a question off of knowledge, off of education, off of research. They're going to just put the question out there, and 80% of your people that you ask, are they going to be knowledgeable in the subject that you're asking about? No. If I ask you about clubbing baby seals, most people don't even know why they club baby seals. Why they club baby seals? I don't know, but it's wrong. Okay? How about if that baby seal could save somebody's life? Would it be wrong then? You know, kind of like the stem cell research. If you go with stem cell research, are 100% of the people going to know and research and know the knowledge about stem cell research to answer a question? No. So what the pollsters do, if they are biased and they want to say that stem cell research is the greatest thing on earth, they're going to ask questions of people on the street, and they're going to say, do you think that stem cell research is great because it can cure cancer? And what would naturally 100% of the people say? Yeah, it's great. What is stem cell research? Half the people will ask that question. See what I'm saying? So you got to be careful, not only when you're asking the questions, but you got to be careful when you're answering the questions, because there's nothing wrong with saying, I don't know enough about this subject to answer that question. Because if you're answering the leading question, then the poll is no good to begin with. You shouldn't answer. No sneezing in class. That's number one. No coughing either. That's number two for you. I heard that little cough while ago. I'm not going to do those. So that's 1.5. 1.5 is just on samples. I meant bias. So the only thing I want you to come from 1.5 is bias sampling or bias statistics. I thought we talked about experiment and observation. Okay. Well, they must be talking about it again, or we going over it again, one of the two. Hey, come. Y'all all right? Y'all sound like y'all sick. I got a friend that come down with like flu-like symptoms the other day, and I was like, dang, it's the middle of August. Have y'all seen something going around with sore throat and stuff like that? Huh? Was it like sore throat and flu-like symptoms? 1.6 is pretty much nothing, so you don't have to worry. I don't think, do we go through 1.6? Okay, somebody look on the, I ain't sent you that outline. I gotta send you that outline. I guess we're just going to 2 points. How many sections are in chapter? Okay, chapter 1 review. So what page does chapter 2 start on? Somebody tell me so I can go right to it. I'm sorry, what?
62.
62? Yeah. Looks like 1.6. I don't even think it has a 1.7. Oh yeah, we have started on chapter 2 because we were starting on frequency, or that might have been my 103 class. That's it. Okay. Frequency distribution. I thought we would be going over that. I told you there is a frequency distribution right there. Now, the main thing to know about a frequency distribution is what is it? Because a lot of people don't even know. It's a chart. Frequency distribution is a 25-cent word for chart or table. It has classes on the left and head count on the right. No matter how much they fancy it up, it's a chart. So if I went through and asked blondes, redheads, and brunettes, that would be a frequency distribution. If I went through and said male, female, that would be a frequency distribution. Flip-flops or shoes, frequency distribution. Brown eyes, blue eyes, other, frequency distribution. All right, class on the left, frequency on the right. Frequency is a 25-cent word for head count. I don't know why they just don't say count. Frequency. That's your frequency distribution. Hold your pinky up when you say it. Okay? Now, there's some things about frequency distribution that they're going to ask. Mathematical questions about frequency distribution. First thing they're going to ask is the relative frequency. Is that a 25-cent word? Yes. For what? Percentage. If there's 30 people in here and 3 of y'all have blue eyes, then what is that of the class? Well, 3 out of 30 is 1 out of 10, so that's 0.1, so that'd be 10%. Yes. So that is your relative frequency, 10%. Or you could just say 3 out of 30 multiplied by 100. And if any of y'all know anything about math, basic math, anytime you take the smaller and divide it by the total and multiply it by 100, that's called a what? A percentage. But we call it now relative frequency. Relative frequency. So I'm not going to insult your intelligence by going over relative frequency, when all of you have been taking the percentages since pre-algebra back in 6th and 7th grade. You take the the smaller number, divide it by the total, and multiply by 100. Now, in order to get the total, you have to, again, I'm not going to insult your intelligence, you have to add all the frequencies up so you can get your relative frequency. You add all the numbers up so you can get your percentage. 30 is in. So 12 divided by 30 multiplied by 100 is 40%. Now sometimes they want it in decimal form, sometimes they want it in percentage form. But you just multiply by 100 and that's the difference. Or move the decimal 2 places to the right. That's your difference. Again, I don't want to insult anybody's intelligence by going over that, but some people go through statistics and don't even know what the difference between a relative frequency and a percentage is. It's the same thing. If you was to construct a bar graph or a line graph, you would put back, wrist, elbow, hip on the bottom, and then you would put the relative frequency or the total, depending on what you wanted. In other words, 12, 2, 1, blah, 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 or you can put the relative frequency. Most people go with the frequency or the head count. Okay? So out of this section, you need to know what a relative frequency is, you need to know what a frequency distribution is, and you need to know how to graph a relative frequency or a frequency distribution, meaning by the head count or by the percentage. That might be a question on the test, just one question. A bar graph. The difference between a bar graph and a histogram. I think I mentioned this. If I haven't, it's because I get y'all mixed up with the 103 because we're covering the same material. Okay? So if I assume something, it might be because I covered it with the 103 class. So, what I may have said this last week when y'all met last, whatever day that was. What's the difference between a histogram and a bar chart? Anybody know? Did I say it? Yeah. The histogram, the columns are connected. What does that have to do with anything? I don't know. I don't know why they just don't call them bar charts. It sounds like to me somebody came up with a name for something and they didn't know what the name, so they said, well, let's put the bar chart together and we'll call it this name. And they call it a histogram. Kind of like a bureaucrat trying to find a job, so they make up one for it. Well, somebody came up with the word histogram and said, you know, we got this nice name for something, but we don't have anything to match it with. Okay, let's take the bar chart, let's squeeze it together, and we'll call it that name, a histogram. Because the bar chart came first. Okay? So, do I care whether you know the difference between a histogram or a bar chart? No. Is it a test question? Yes. Why? Because people don't get it wrong. Well, most people don't get it wrong. So just remember, bar chart is separated, got space between the bars, and the histogram doesn't. That is the only difference. So those are bar charts. Pareto charts is a bar chart of the percentages. Write that down. A bar chart or a histogram of the percentages. Remember a while ago I told you that most bar charts are done with the head count? Well, what if you use the relative frequency? Then it's called a Pareto chart, which is a what? A bar chart of the percentages. You're starting to see a little bit of redundancy in this. I don't know. But most of the time, if you just do what you learned back in pre-algebra and just kind of make it through the bull crap out of some of these words, you can make your, you can get a decent grade out of here. I mean, half the stuff that's in here is made up stuff. I hate to say that, but it is. I mean, think of it. A frequency distribution. You've been calling a chart or a table since pre-algebra. A bar chart versus a histogram. They just touch. The relative frequency versus a percentage. And then a Pareto chart versus a bar chart. A Pareto chart is just a bar chart with the frequency distribution, or whatever it's called. Okay? Relative frequency, I'm sorry. Even I get mixed up with all this junk. The math is the same that you learned back in pre-algebra. But they're going to ask you something here in just a minute that is not normally found, and that is the classes and all that stuff, how to form the classes, class boundaries and all that. And a lot of people don't think about that. Now that is important, and that is a test question because a lot of people don't know how to do it. We talked about, we may have, I remember talking about it either with y'all or the 103 class as a pie chart. Now, I'm not going to ask you to construct a pie chart. I'm just going to ask you to be able to read a pie chart. And most of you have been reading them since pre-algebra. Okay? If I have 50% of my income going to my housing, then if I make $1,000 a month, what is my housing budget? $500, 50%. You take 0.5 and multiply it by the total. That's what I want you to be able to do. So beside pie chart or pie graph or whatever they decide to call it in this book, put be able to read. That's all I want you to be able to do. I don't want you to construct. I just want you to be able to read. And they'll probably show you an example on the next page. There it is. So if 2,000 people graduated in 2009, or how many people are going to have some college or no degree, blah, blah, blah. 17% of that. So you take 7.17 and multiply by 2,000. 2,000 people polled or whatever. Okay? 2,000 people polled, 0.31 times 2,000 would have high school diplomas. So that's a good test question right there. And all I got to give you is how many people are polled, and you tell me how many people got a high school diploma. Pretty basic math. 2.2. Thank you. Good gosh, got like 10 pages of homework. Okay, how to construct a frequency distribution. One of the first things you do in statistics with data. Does anybody know what the first thing you do with it? Put it in, no, good answer though, but not yet. Put it in what? Blank. Order. Put it in order. First thing you do with any type data in statistics is you put it in order. So you can, first of all, start a frequency distribution. So if you were given this data right here, the first thing you would do is put it in a Excel spreadsheet and put it in order. Now, I'm going to show you how to put it in an Excel spreadsheet. I'm going to show you how to put it in calculator. That's usually the quickest way to do it, because if you ever sat there and tried to put these numbers in order, it's real tedious. And if you leave one number out, it's over. It's wrong. So it's better when you actually can put it in a calculator or put it in an Excel spreadsheet, then highlight the column, then put it in order. It's usually better when you do that. And I'll get to that in just a minute. Now, once you have the data in order, you've got to do some kind of classes on the left-hand side. Now, that is dependent upon whatever you're doing. All right, if you just want to know how many different numbers you got, then you just list the numbers and you do a tally and do the frequency and do the relative frequency, or do the head count and then do the percentage. All right. Now, if you wanted to know how many between 1 and 5, between 6 and 10, between 11 and 14, between 15 and 20, that kind of thing, that's when you're dividing it up into classes, and that's when we're going to get into the little bit of mathematics having to do with frequency distribution that a lot of people don't know about, unless you've taken this course before. Or you usually don't talk about it on the sidewalk. Oh, there's the histogram, a bar chart that connects. That's all you need to put, because it's the same damn thing as, there's a histogram. No different from a bar chart. Okay, here we go. This is where we start talking about the mathematics. And the first thing you got to know is the upper class limit and the lower class limit. These are test questions, so you might want to put stars beside them, and you might want to highlight them, because these are test questions. These are lower class limits: 25, 35, 45, 55, 65. They are the lower number of the class. The lower number of the class. So you could pretty much fill in the blank for upper class limit. The higher number of the class: 34, 44, 54, 64, 74. Each one of these are classes. Each one are classes. Each class is made up of a lower class limit and an upper class limit. Now, you're going to need to know the definition for an upper class limit and a lower class limit to be able to find all the other stuff after on the next page that they're going to ask you for, like the class boundaries, like the midpoint or the mid-class, or whatever they call it. All right? So the first thing is, make sure you know what these guys are. Again, I'm going over some material that most of you have probably had before, so I'm trying to go over it just to review, but I'm not wanting to insult your intelligence. So I know I'm going over some stuff kind of fast right now. I did see those questions. Those questions are BS questions, and I'll go over them later. They're not test questions, so don't worry about them. Whoever sent them, I don't even know what chapter they come from, because I've never seen them before. Okay, so those questions I pulled up a while ago, chill on them right now. I'll go over them when I go over some more questions, but I've never seen those questions before. So I'm either going to take them out or I'm going to explain them to you, one of the two. But they're not test questions, I can tell you that. Okay, let's get to the midpoint and all that stuff. Are you ever gonna? Okay, there we go. Class width. Here's the second question on the frequency distribution math. The class width is the largest data value plus the smallest data value divided by the number of classes. All right. I don't do it that way. I'll show you how I get the. What is 3 minus 3.5? 0.5. That's the class width. What is 4 from 4.5? 0.5. Class width. 6 minus 6.5. 0.5. The class width on this frequency distribution is 0.5. That's how you find the frequency. Class width. If you want to take the upper class limits away from each other, you can do that. What is 3.99 minus 3.49? 0.5, Hubert. That's right, class. So what's the class width on this whole frequency distribution? 0.5. Simple as that. Lower class limit or upper class limit minus the lower class limit. Now, you can't take 4 from 9.5. They have to be consecutive. You take 5 from 5.5, you take 5.5 from 6, you take 6 from 6.5, you take 6.5 from 7, 7.5 minus 7, and so on. You don't go, okay, 8 minus 11. No, you don't do that. They have to be consecutive. That's how you find class width. That's a part of it. I'm waiting to find the midpoint. Stem and leaf plot. Might want to write that down. That's where you basically have a quantity and you show how many of that quantity. The 40s, the 50s, the 60s. In the 40s, you got 42, 44, and 45. That's 3. So in the 40s, you got 3. 44, 43, and 45. In the 50s, you got 51 and 52. You got 2. In the 60s, you got 60, 61, 62, 63, 64. That's 5. So you got 5. A stem and leaf tells you how many you have of that value. It's kind of like a box plot. Okay. There's a stem and leaf right there. How many 70s? How many 7s do we have? Or 70s? There's 4. 71, 72, 73, 74. Or you could also do it. There's a 74. Here there's an 82 and an 86. There's 2. Here there's a 91, a 92, a 93, a 97, and a 99. So there's 5. 100s there is 6. 101, 102, 103, 105, 105, 109. That's a stem and leaf. And of course, with a stem and leaf, what can you see? If it's a what? Bell-shaped curve. And this one is a little bit skewed right because the hump is a little bit to the left of middle. So a lot of information's right here. So that's why it's a little bit skewed right. It's always opposite where the hump is. If the hump is to the left, it's skewed right. If it's to the right, it's skewed left. But pretty much it looks like a normal curve. This one also looks like a normal curve. And lots of times with a box plot, you can tell, or stem and leaf plot, you can tell. This book goes all around the world to teach one thing. More stem and leaf plots. Dot plot is the same thing as a bar chart, except you take the quantities 10, 20, 30, 40, 50, and you plot those points. So I'm not going to spend a lot of time going over that. I don't think they're going to get the class boundaries and midpoints. Maybe they will in chapter 7. What page is 2.3 start on? 107? I'm sorry, 2.3. We're bogging y'all down with a bunch of busy work. Okay, there we go. Okay, this is where I was talking about biased misinterpretations of graphs. Now, when you're looking at I don't know why they didn't show you midpoint, but we'll get to it. Don't worry, because you have to have the midpoint to do the mean and standard deviation of a frequency distribution, which is in chapter 3. So we'll get to that. Don't worry. It should have been in that section there, the midpoint, but evidently they're going to do it later on in another chapter, chapter 7 or something, the way this book is spread out. I'll show you a good misrepresentation. Usually you need to look at the size, like here. Opinion regarding the Chavo case. Chavo, whatever. Why is this misrepresented? Exactly. What's the difference between 54 and 62? 8. But if you look at this, it makes it look like what? That the whole Democratic Party is going for whatever. I don't even know what it's talking about. Okay? Because the only reason I said Democrats, because it's got Democratic Party down there, Republican and Independents. See the difference? See, it's showing a big old rise. And it makes it look like the Democrats are ahead by 200 votes or whatever. But it's only what? 8. That's a misrepresentative graph. Where do you see a lot of misrepresenting graphs or pictures, pictographs? These are called pictographs. They're pictures showing statistics, newspapers and TV. Why? Because a statistician is off in a corner somewhere in a little closet, office, crunching numbers, and he or she does this report and gives it to the what? The producer. And then the producer gets a hold of it, and what does he or she know about statistics? Not a dat-blame thing. So when they put together the pictograph to show how many barrels of OIL were sold to the Saudi Arabian government and how many were sold to the U.S. government from Saudi Arabia, they're going to show, they want the drama, right? What sells in news? Drama. All right, so they want to. This is boring. Let's get it. Let's I don't know, pep it up a little bit. So they put these big old graphs together, and they don't even think about it because they're not a statistician. So when they present the material, what does it look like? It looks like this. Okay. What I'm saying is, when it comes to statistics and it comes to stuff that people are passionate about, better watch it because it can be biased. Trying to find the one with the barrels, but this book probably done away with it because it looks okay. Here's a good example right here. Soccer participation. Soccer participation 1991, soccer participation 2007. Now, you got to look at what they're saying over here. It says, problem, soccer continues to grow in popularity blah, 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 blah. In 1991, there were 10 million. Everybody got that? But 7 years later, by 2007, it had gone to 14 million. What's wrong with the picture? Not that big. Let me give you an example. Look at this ball right here. This ball could fit pretty much what? Into that black, what do you call these things? Pentagon? 1, 2, 3, 4. Dang old Pentagon. Dang old Washington, D.C. Dang old, that ball could fit in that black Pentagon right there, right? How many of these pentagons are visible on this ball? Let's count. 1, 2, 3, 4, 5, 6. You could actually take this one and make 7. You could take this one and make 8. This one and make 10. So how big is this ball compared to this ball? 9 or 10 times bigger. What does the math say? No. That's what I heard. Only 4 million greater. So if you did the what is it? 14, I done lost it. 14 million divided by 10 million, you don't get 9 or 10 times bigger. You get like 1.4 times bigger, or whatever the case may be, 0.14 times bigger. You don't get what the picture is showing. This is a prime example of what the media does, okay? It's 9:02, I think, all right? That's what the media does. They take the media and they take the data, and the data is not interesting enough. What do? They kind of give it a bump. When you're dealing with the media and you're dealing with statistics, you've got to be, 1, a little bit educated. 2, you need to know the subject area of what they're talking about. And 3, you might have to do a little bit of what? Research. Because if you don't, then you'll get to a point that the media and the statisticians that work for the media outlets or whatever, they'll basically be telling you what? No. The media wouldn't do that, would they? Shut up, Hubert. Teach math. Huh? Thank you. 107. There. Now these are 2 good examples. If I was to pick questions to go on a test or homework questions that are worth a flip, not like those I saw before class, there would be the soccer ball and this one. So you might want to mark them. What's wrong with this picture? Well, what's the difference between 7.5 and 726? Well, let's do that. Somebody take your calculator and divide 726, so let's say 727 divided by 8. Somebody do that right quick. Some of y'all on the calculator drill team in high school. You know, twirl them around on your fingers when you were in high school, like a basketball. For you people that can't make change in the real world. What do you get? 727 divided by 8. Okay, so that barrel should be at least 96 times the size of that little barrel. Golly, it has to do with OIL. Wonder why they're not showing the truth. And it's also taken U.S. Energy Information Administration. That's what they're putting out. So let's see. Let's take this guy right here. I'm going to show you a trick I learned in the war. That's a joke. Let's see. All right, so let's take this guy and let's insert. I'm not going to be able to insert it. I'm going to have to copy it. Hold on a second. Just give me a second to do this. I can do it. I know I can. I can't copy it. Okay, we'll do it the hard way then. Copy the whole bit one down. Okay. And we call it barrels. Both educate caption. Now I'll go to the white page because I can't copy on the transparency. I have to put it on the white page. So, okay, where is it? Okay, there's that. Oh, well, that's not right. That's the big one. I thought I brought in. Okay. Hold on. I'm doing this for y'all. Y'all know that, don't you? I don't care less. There. All right, so let's take this guy and let's put him there and do another one. Put him there. Y'all see the point. And that's what you have to do when you're looking at pictographs. The barrel is showing 4 times as much, and what did you come up with? Just rounding numbers, what did you come up with? It's how many? 90 times bigger. Well, why wouldn't they show that? Why would they mislead you like that? Well, it has to do with what? Look at what it has to do with. Now this is the book, okay? I'm not doing this. What does it have to do with? Well, let's go back and look. It has to do with what? U.S. Strategic OIL Reserves. Oil reserves. Well, oh, I'm sorry, OIL. I said it wrong. When you say it, you only say it, there's 2 ways to say OIL, and there's the redneck racist way of saying it, and then there's the correct way. I say it the redneck way, so I don't say it, I just say OIL. Anyway, why would they mislead somebody on strategic oil reserves? Well, they actually make it look like we have what? Less oil, but they don't want to show that we have what? More. Why would they do that? I'll let you come up with a. What is OIL reserves? What are they? That's the big tanks that we have that are for what? Emergency, Schubert. That's right, class. That's what reserve is for. SAT word, all right? Okay, why would they want to? I don't know. You come up with that. And this is the U.S. Energy Information Administration. Next. And of course, here's another one. What's wrong with this one? Well, this is the cost of raising kids. Housing, 33%. Food, 18%. Transportation, 15%. 11%. Exactly. And that's one of the number one things that happens with data presented on media outlets. Now, If they put an other in there, then that's good because they're making it equal to 100. Sometimes they don't put it in there because it is something stupid like, I don't know, pacifiers or something like that, and it's not like 0.01%. Sometimes they leave out stuff like that, and that's okay. But when they show you something and they show other, and they still don't equal 100%, then that's an indication that you're being deceived. What's wrong with this one? Is it a legitimate, or is it, well, 52 plus 38, that's equal to what? 90 and 10%, so it equals 100. Is it legitimate? I would say it's legitimate. Why? Well, it equals 100. What else? This is 50%. This is almost 40%. You're not talking about a distortion here, are you? No, that's pretty legitimate. But you got to be able to tell. And if you're not able to tell, you're one of those people that can't make change. You're one of those people that, yeah. You ever watch the Waters World or Jay Leno, Jay Walker? You ever watch after the 2008, or I don't know, 2008 election, I don't know, Howard Stern went out and asked people if Sarah Palin would make a good vice president under Barack Obama, and people said, yeah, she'd make a great vice president. I think she's going to do good. They just voted, but they had no what? They had no idea who they voted for or what they voted against. No idea. This is Howard Stern, this ain't me. Okay? Like he went out and polled 100 people that voted and asked them questions that, do you think Barack Obama and Sarah Palin are going to make a good team since they won the election? Oh yeah, I think they're going to make a great team. And they voted. Okay? What I'm telling you is, you can't believe everything that's being presented to you. It's kind of like the old saying, or you ever been warned of the con artist? Well, can con artists be in media, and can con artists be in statistics? Yes, they can. And you got to watch for them. And what is the only way to watch? What is the only way to be? I don't know how to say this. No, hold on. Yeah. How is the only way to fight against stuff like this? To be what? Starts with an E. Educated. That is the number one way to be able to spot things like this. To be educated. Because the best way to keep somebody down is to keep them what? Ignorant. Think about that. Question. And I think you got the point of dishonest pictographs. I'd like to get to chapter 3 because that's where we actually start doing math. Okay, so that means we're almost through with this section. Let's see, 116. Okay, so we are finished. So let's look at chapter 3. I'm going to just take a minute and show you all of these things right here we're going to cover. 80% of the test, 80% of your Unit 1 test is going to come from here. All right? Now, I have told you what's important in chapters 1 and 2. Qualitative data versus quantitative data. Discrete versus continuous. What is the difference between a parameter and a statistic, a sample and a population? What is a placebo? What is an experiment versus an observation? What is a random sample versus a systematic random sample? Why does that barrel look, is it proportionate to this barrel? Is this deception? That kind of stuff. Those are test questions that's going to come from chapters 1 and 2. All right? 20% of your grade, or 20% of the non-bonus questions on your test. All right? The 80% is going to come from here. Now, we're going to spend probably the next week, probably between now and next, whatever, Monday, we're going to spend on these sections. Because I guarantee you that there's going to be a section in here that you've never covered. And that is finding the mean and standard deviation of a frequency distribution. All right? I doubt very seriously, unless you've had a very good math probability instructor, that they even covered that, because most people don't even cover it. They just cover how to find the frequency, how to find the standard deviation and the mean of a bunch of test numbers, a bunch of test scores. But a mean and a standard deviation of a frequency distribution is a totally different animal. Okay? So we will spend time going over that also. So right now, okay, everybody get your crayons out. Right now, you should be working on Chapter 1 and Chapter 2 material. I had to speak slow for those people that want to go on to Chapter 7. Okay, Chapter 1 and Chapter 2 material. Chapter 1 and Chapter 2 material. How many emails do you think I'm going to get? Probably 2. I don't understand 3.3. See why teachers get irritated? As I tell my 9-year-old son, you see why I get irritated? You see why teachers get irritated? It's Bush's fault. Oh my gosh, you know, I wasn't able to take roll the other day. You know how many emails I got? 7 emails. You need to take attendance. Oh God. Well, that federal government, they cracking down on that 1%, half of 1% of the population. I'm glad we got such a law-abiding federal government. Emails, erasures. What was that, Wednesday? Everybody was here Wednesday. Did y'all know that? Yep. All right, today is Monday. And I did 103. That's the wrong class. 4. The Shore. Bolt. Here. Davis. Here. Edwards. Here. Finley. Here. Garcia. Here. Goodson. Here. The Hamiltons. Here. Hill. Here. Hovey. Here. Jenkins. Here. Jones. Here. Laney. Not here. Lindsay. Here. Mahaffey. Here. Martin. Mitchell. Martin. Mitchell. Here. Morgano. Here. Painter. Here. Plummer. Here. Reese. Here. Simmons. Here. Stafford. Here. Stone. Here. Tarbert's here. Vickery's here. Vincent. Here. White. Here. Worshball. Here. And Wolf. Here. Now, does anybody have any questions pertaining to anything we've done so far? Does everybody know what chapters of homework you need to be working on? Say it one more time. One more time. Anybody want to bet me a biscuit? Bet me a biscuit. I'll get an email. Anybody want to bet me? Yeah. Bet me a biscuit. I will get an email saying what chapter we're supposed to be working on. All right, y'all get out of here. Have a good day. Glad y'all got to see me.